Okay, I'll make sure this is all good. Start video. Okay, start video. All right, thank you, big. Oh, am I sharing screen? I am. Okay. Okay. Hello.
Twice. It's kind of big.
Let me go to here. All right, so gang, we're gonna have a little pre-lesson today, and it's kind of interesting. My weird doctor appointment last week, which was super weird. Some of y'all were like very interested in how that was gonna go. So that kind of weird doctor appointment I had lends itself perfectly to something I wanted to talk to y'all about anyway. So we're gonna do it like a little pre-lesson. I'm recording it for the people who aren't here before we start lab. So are all you guys comfortable somewhere? You can see the screen? Everybody's good? Okay, and everybody can focus on the screen and not look at the worms because we're looking here. So this is a follow-up on all my weird spinal stuff, but it's perfect segue into some stuff I wanted to cover before we start dissections. Where's Cole? Okay, so follow up. This is off topic, sort of, some of it, not all of it. So here we go. So you've seen this before, right? I sent this one with you guys. All righty. Now, we're going to take a closer look at these little vertebrae here. So my MRI included this exact kind of image, showing this exact same kind of cross section. So it looked kind of like this. So this is what we call, wait a minute, Darcy, listen, okay. This is what we call an axial image. So this is the stuff I want to make sure that you guys, we are recording, right? We should be recording. Good, it is. All right. So this is the stuff I wanted to go over with you guys. These body planes and directions, and this is perfect lead in. So an axial image, so this refers to the perspective or the plane or the angle from which you're viewing that image. So an axial image is like a top down cross section. So we're going to talk about what does that actually look like? What's that mean? So when you're observing a body or images of a body, it's important to be clear about the perspective of the observer in relation to the body being observed. Otherwise, it's relative. So these are the terms we use. This plane, like this purple plane here, we can call this a frontal or coronal plane. Usually it's a frontal plane. And then this here is what we call horizontal or axial. So the image I was just telling you about is axial. So it's like the cut was made in this direction. Where did Drew go? Oh, I just couldn't see you. Okay. And then we have sagittal or longitudinal. Longitudinal is often what we use. That's this one here. So, or no, this one, where is that? Oh, that's just right in the center. Okay, median. Median is if you go this way, right? You use our bilateral symmetry like a book. You just divide us down the middle. And then they have this parasagittal. So these sagittal lines and parasagittal are basically like we've just moved slightly off center. That's what they're saying. The big ones for you guys are the coronal, the axial, and the median, okay? And then we also have to use the right terminology when we're talking about in relation to what. So we tend to call this part is the superior region. And then you have the inferior region. And you can also call this anterior. Sorry, the anterior is the front part of your body right here. And the posterior is the back part of your body right here. The other words for those are ventral and dorsal. So for human, it looks like this. Now for a dog that is not bipedal, you have to think about it. Their anterior end is their head, right? And their posterior end is right where their tail begins. So it's actually, we tend to use, when we're talking, we use terminology that's derived kind of from the embryologic development. So in embryologic development, one of the big things that happens in vertebrates is the formation of an alimentary canal. So that's the tube that runs mouth to anus. So that's the beginning, anterior, posterior. So wherever your mouth is and wherever your anus is your anterior, posterior, right? And then we have, like I was saying, we have dorsal and ventral, like a dorsal fin on a fish is on its back. That's the spine side. Ventral's the front side. We have our organs are all accessible really through our ventral side, right? That's where you do surgeries and things. So here's our example, give you an idea of why this is so important. So let's say that you are at your house facing east. There you are. You're at your house and you're facing east. Everybody see you?
Yes.
There you are. Okay, and I'm in my house and I am facing north. Where am I? I'm down here. Okay, this is me and this is you. All right. And we want to meet at the ice cream shop, but you don't know where it is. There's the ice cream shop right there, kind of in the middle. You see it? So I know how I will travel. I didn't mean to click that one quite so fast. Whoop, whoop. Oh, wait. I went back. Sorry. So I know how I'm going to get there. So I'm going to tell you what I know. So I'm going to give you directions from my perspective. So you're going to follow these directions from your perspective. So if I tell you walk straight to the first street and cross it, you're going to do that, right? And then if I tell you turn left and cross the street, you're going to turn left and cross the street. And there you are. And then if I tell you turn right and walk until you reach the next corner, you're going to do that. So what if I tell you to turn left and cross the next street? Well, that's me. And where am I? I'm at the ice cream shop. Are you at the ice cream shop? No, because we were using very relative terms. Like if I'm saying left and right, you're going to turn right. Which way were you facing, right? So the ice cream shop's going to be on your left, I say. Well, this is my ice cream shop. Well, this is this. What is this? Not the ice cream shop. So here I am. I've made it. Where'd I end up? At the ice cream shop. And where'd you end up? You ended up at the tire service. This does you no good, right? This does you no good. And I got my ice cream and I'm happy. I'm like, yeah, and you got a wrench. That stinks. Okay, so it's important that we use terms that aren't so relative. So cardinal directions, right? Like north, south, east, west. If I'd have told you that, that would have helped you get to the ice cream shop, but I didn't tell you that, did I? So cardinal directions make clear the position and movement of a person in relation to Earth. They're not relative to the way you're looking or your position. So scientists, physicians, and other healthcare workers use anatomical body planes and directional terms to describe the location and position of body structures in relation to these established norms. So nothing is relative. So below our diagrams, body planes, these are the ones we just talked about, and you'll be using some of these in your dissection labs. So the other thing that we didn't talk about before is this one, proximal and distal, and it has to do with where the center of your body is. So if, say I had a tumor, like right here on my leg, you could say it was in relation to the kneecap, it's proximal, it's closer to the center, right? But in relation to the hip, it's distal. Does that make sense? Okay, so there's that. I'm too fast. Fat fingered everything the last day and a half. All right, so here's this axial plane, right? This is the one we're looking at from my MRI. So here's the cool thing about the axial plane. You can move the axial plane up and down the body. It can move. Woo, it doesn't matter where it moves. It stays axial because you didn't change its position. And anywhere the plane lands, you just bisect at that point. So there you go. Woo! All right. So how this works is, isn't that kind of fun? So you imagine that you're able to look up at this section from the bottom, or you could look down at the other section from the top, right? So keeping that in mind, to understand this image, what we need to know then is, using our new terminology, we need to know if we're looking up from the bottom or down from the top, because we know it's axial. So here's how we know. If I told you this was ventral and this was dorsal, and I told you inferior was down here and your superior is near you, are we looking up from the bottom or are we looking down from the top? We are looking down from the top. That is correct. So this would be like lung, and right here is going to be, this is a vertebra right there, nice and clear, right? All right, so what's this mean? So let's zoom into this and get a real close look. So this is the cool thing the doctor did. So you can take an image of a healthy disc, so like another axial cross section from another part of the spine. And you can measure the diameter of the spinal cord, and you can measure this cerebrospinal fluid around it. You can see those distances, and then you can move to the axial image of, like in my case, it was T2, T3, right? Where I had this disc that had ruptured and oozed out. And then you can compare those measurements, and you can tell whether or not that ruptured disc is compressing the nerve root. And in my case, it was not my herniated disc. It's not pressing anything. So that's not what's causing my pain. And we only found it because we bothered to look for it. People could be walking around with herniated disc all the time and not even know they have them. I just happened to be looking for it, and there it was. Ta-da! So we went down the wrong path for a little bit because that was an obvious thing. It's like, oh, that's a problem. That's an anomaly. How do we deal with it? So what is causing the problem? It's called brachial plexus. Do you know what your brachial plexus is?
No.
Okay, you're going to learn what your brachial plexus is. This is a little off topic, but it's really, really interesting stuff. So your brachial plexus is this bundle of nerves. They come from your neck, right, down into your upper trunk, and then they create this network that connects all of the nerves in your arm. Think about how your hands are they can do these tiny little dexterous things, right? And that's because you have all these nerves that come through, and they come through this brachial plexus. It comes this way it hits right here, and in your armpit right here, there's this massive network. And the doctor gave a good analogy. It's kind of like a train station. You got trains going in, switching tracks, coming out. It's a big old bundle. So you have, these are the main nerves you've got here. You've got your musculocutaneous, you've got your axillary, your median, your radial, and your ulnar, and they come from these different vertebrae. So you've got various nerves. You got nerve root branches out, joins with other ones. It's kind of crisscrossing. So there's this thing called Parsonage-Turner syndrome. Yay, me. Parsonage-Turner syndrome. It's also called brachial neuritis, brachial plexus neuritis, brachial plexus neuropathy, idiopathic brachial plexus neuropathy, neuralgia, amyotrophy, and PTS if you don't want to say Parsonage-Turner syndrome. So it's a progressive. What's progressive mean? It keeps getting worse, or it keeps moving along, keeps progressing. Nerve disorder of the brachial plexus, and it's rare. You get 3 cases out of every 100,000 individuals per year. And get this, it's young males, 3 to 2. Everybody else, here's your ratio. Everybody else, 3 young males, 2 to everybody else. So I need to go buy a lottery ticket or 50 because this is weird that I got it. So it's sudden severe shoulder pain, upper arm pain. Yes, checkbox, checkbox. It's really acute. What's acute pain mean? It's sudden and it's strong, as opposed to chronic pain, which you have like all the time, right? It's really sudden, it's really strong. And that phase can last for a few weeks, or it can last for a few months. In my case, it lasted about 8-9 weeks, long time, long time. And then you go to what they call the chronic phase. And this is characterized by wasting and weakness of the muscles, which we call amyotrophy in affected areas. So what's wasting of a muscle mean?
Not using it enough.
Yeah, it deteriorates. It just kind of doesn't function and it shrinks, right? And that's what weakness is. Not quite die, but it becomes sort of useless. So it usually affects your upper arm, shoulder. It would be terrible if it got the legs and diaphragm, but sometimes it does. So cause is unknown. That's great. But it's definitely an autoimmune response. Oh, yay, autoimmune disorders. Me again. It's not really an autoimmune disorder, but an autoimmune response can cause it. That's fun to understand, right? Infections, injury, vaccines, childbirth, other factors. Infections. I had a viral infection right before this happened. Recovery can last months. I've seen as much as 2 to 3 years before you get full use of the muscles back if they're affected.
Wonderful.
And 70 to 90% make a good recovery. Not everybody. And about 25% have it repeat more than once in their life. It just keeps coming back. So
You're rare stuff.
this is a cool little map. All right. This shows, they took the brachial plexus and they broke it down kind of like a train map, right? This is sort of like a MARTA map, and it shows you where they go. So this is the cool part. This is where it gets really, if you like interesting scientific stuff, how did they find that out? This is really cool. So this simplified graphic is going to show which nerves lead to which muscles. So they can test the nerve signals in the muscles and tell which nerves are affected and thereby which muscles are affected. So how do they do that? Oh, this is fun. So it's called a nerve conductivity test, or NCV. And the first part of this test measures how fast an electrical impulse moves through your nerve. And they use it to identify whether the nerves are actually passing the signals, okay? So they give you these 2 electrodes, these guys here, these dudes here, they stick them on you. And then one is going to stimulate the nerve with that, they say, a very mild electrical impulse, and the other records it. So they repeat this for all the nerves. Now, you did see how many nerves there were. Okay, get an idea of that. Keep that in your head, right? They repeat this for all the nerves. And then they calculate the speed by measuring the distance between when it was stimulated and when it was received. So if you put an electrode here and here, and then you send a shock, first off, the muscle's going to contract. So I'm laying there and it's like, and he did it about 3 times on each of these nerves. So he would hit the nerve gently, a little more. So I'd be like, your whole arm jumps. And if you're wondering how it feels, it's a shock. It's a decent shock. It's worse than, I touched the doorknob and I got shocked and go, ugh. It's stronger than that.
Oh, yeah, I was about to
And
ask you
it's stronger than that for sure. But it's not like, oh my gosh, I'm going to die shock. The first one, like he said, this first one's a zinger. And he was right. The first one was a zinger. I was like, whoo! And then you kind of adapt to it. You sort of settle in and get used to it. And he can increase or decrease depending on what you tolerate. So since the nerves are being stimulated, the muscles respond by moving, which means your hand or arm moves totally without your control. It's freaking weird. So this part of my test turned out normal. All my nerves are now sending messages, okay? which is good. It means I'm kind of out of that acute phase. I moved into this chronic phase that we're talking about. The second part is the electromyography. This one is a little different here.
Sure.
So this, no, not at all. So this measures the response to the muscle, guys, of the electrical activity, okay? So during this test, one or more small needles called electrodes are inserted through the skin into the muscle, and they record the electrical activity. They don't do anything. Hang on, just listen. They record, okay? So there's a monitor. It's called an oscilloscope. So it's listening to electrical activity basically, and it puts it up on the screen with the graph, and it also gives you a sound. They've made a sound with it. So muscle tissue does not normally make electrical signals unless you're moving the muscle. So they insert the electrode, and there's this brief on the screen because you've irritated the muscle because you just stabbed something into it, right? And then it gets silent. There's nothing going on the oscilloscope screen, and there's no sound. But when you then contract the muscle lightly, contract the muscle more forcefully, you can watch it appear. So I'm going to show you kind of what it looks like. Now this part, it can be really uncomfortable, as you imagine. Sometimes it can be downright painful, but it's really cool. So I kept focusing on how cool it was. Now, I'll show you in a minute what's left, but I do still look like I was a pincushion. This was last Wednesday. We're talking 6 weeks
You
ago.
have one or more.
I had 19.
Oh.
Yes. The first one was over here. I was just laying on the table, and he's like, and this is how they do it. They don't do this. They go pop, they pop, pop. Yeah, it was real fun. Okay. So the needle, this is the cool part. Okay, this needle is actually 2 needles in one. It's called a concentric needle electrode. So what it has is this tiny little wire in the middle. It can be tungsten or like silver. There's all kinds of things they can use. And then another part on the outside. And this guy in the middle, this little wire needle, is completely insulated. Okay, so it can't take electrical activity in from up the shaft of the needle. It can only take it on the tip that's exposed. So what it does is it measures the potential difference in electrical. Are you guys paying attention? Between here and here. There's a gap, right? And you've got an electrical impulse coming, right? So it's measuring how long did it take to get from here to here. And it's using that information to give you on the oscilloscope these little marks for every muscle contraction, because your muscle fibers, like they get a response and they actually contract a little, and they kind of work like a ratchet. So it's really kind of fascinating. So my needle was pretty small. It was a 26 gauge, 1.5 inch needle. I know because I took a picture. Yes, I took a picture of them before you came in the room. So I did look it up because everything online says they're like acupuncture needles. They're really small. The largest needle used for acupuncture is 26 gauge, the largest one. So it is technically like an acupuncture needle, but it's smaller than an injection needle, but it's not small. So you feel it. They're not bad. Most of them weren't bad, but I'll get there and tell you. So this is what it looks like when you insert the needle. You get this little, and it actually makes the little sound, and then you get nothing because you're not contracting the muscle. Cole, Michael, come on. When the needle remains still in a healthy muscle that's at rest, you get this. Not much, right? So pop it in and hold it still. You get very steady hands, thank goodness. Rest the muscle, nothing happens. Then you're asked to contract the muscle, and you get these regular or relatively regular looking contractions. And you can look it up online. Mine's neater than they actually look, but you can look it up and listen to them because it actually makes a neat noise. It's a repeated pattern. And then here, you contract it more forcefully. You're going to get bigger waves, and they're closer together, right? All right, now, when your needle remains at rest in an atrophied muscle, it looks like that. And if you try to contract it at all, it is just a mess. There's no pattern, and it goes the whole time. There's no little pop, pop, pop. It just makes this terrible noise. Sounds like, you know, I don't know, boxes falling down the stairs. It's crazy, right? So I had one muscle that did this. One. It's not good news. It's this muscle, though. It's called the pronator teres. It's right here, this guy. Okay, now I'm gonna show you what it does. All right, so hold your arms out straight in front of you, palms up. Now rotate, don't move your shoulder, but rotate your palm down. That's your pronator teres. The fact that you just did that is because your pronator teres allowed you to do it. So what is it about an atrophied muscle that's gonna cause a different waveform? What makes it do that? This is where the coolness comes in. All right, this is super cool. So here's a cross section of a muscle. This is a healthy muscle. These are your nerve fibers, nerve bundles, okay? You've got these bundles they're composed of other fibers, those are composed of cells, and it just gets like into smaller and smaller. It's like a Russian doll, right? And so these large fibers, they've got no problem. They contract at a steady pace, right? If they receive regular, even electrical signals, it's this nice, even contraction, and they produce a nice, even contraction. If your muscle atrophies, however, they shrink up. And the space between them fills in with like adipose tissue that's fat and other just sort of like filler tissues. And they can't do this nice contraction. So if my brain tells my pronator teres, like I'm laying there and he's saying, rotate your hand, and I'm rotating my hand and it doesn't hurt me, or it's not hard for me to rotate my hand because I'm at the beginning of this. I don't know what it's going to look like 3 months down the road, but I'm rotating my hand. And as I'm rotating my hand, my brain is saying rotate, and my muscles are going, I'm trying so hard. So when they're trying so hard, you're getting this, right? Because they're trying so hard to contract, and it's completely irregular, and these little tiny guys cannot keep up. So that's what happened. So, and just to show you, the top of the pronator teres is right here, okay? So he stuck it 3 times, and he kept telling me, relax it, and I'm trying to relax it, and it's making a ton of noise. And then he came back and did it 2 more times. So this is what I'm left with for my pronator teres. That's this one. And you can see these are some of the others. And he actually, this is the big one, because I got stuck 5 times here. And none of the others really hurt too bad. One on the back of my neck hurt. This hurt like crazy. And when every time he did it, and I was like, he's trying to relax it. And I'm going, okay, I can't relax anymore than I'm trying. The rest of my body's like, because it really hurt. I'm trying to relax. So now we know which muscle is in trouble. So now how do we know which nerves had a problem? So you work backwards, basically. You follow this map and you work backwards. It's a process of elimination. It's really, really cool. So how does that work? So we take all this extra stuff out. We'll make it really simple. Where's the pronator teres? Which muscle is there? It is right here. Here's your pronator teres. It goes to the median nerve. Okay. So now what do we do? So we're going to look at a more simple diagram. We're going to take some of this extra fluff out. So let's look at this one here. This is pretty simple, really simplified. So we're going to trace its path back. So the median nerve is going to split here and here. It's got 2 intersections. So now we got to ask, are there any other muscles coming off these intersections that had problems? Were there? Nope. I only had one muscle that was a problem. So we know it's not here or here. It must be on the median itself after they join. So the problem is somewhere along that nerve. So how do we know where it is along the nerve? Here's your pronator teres. There's where your nerve branches off. See it right there? So it branches off right here. There's nothing below it. None of these guys have a problem. And nothing above it. So that problem is actually right in this joint somewhere, right in that junction. So that hopefully means it is pretty isolated. Thank goodness. All right, so now what? Next, I'm getting an MRI of my brachial plexus right in here because he wants to make sure there's nothing else wrong. He said, if you didn't already have autoimmune connective tissue disease, I wouldn't bother. But since you do, we're going to go look at it. So I'm going to get an MRI. I think it's Friday. I'll sit there on the thing again and it'll go bang, bang, bang around my head for however long. So pain is less now, right? So I've moved from the acute phase to the chronic phase, and I can expect this muscle to weaken and waste over the next several months. I don't know what that means. So it can be very slow, like I said, and it gets worse before it gets better. And now the pain is better, but the muscle is going to keep getting weaker. And I don't know if maybe I won't be able to do this, whatever, but maybe I will. But they do physical therapy, and you can do all kinds of stuff to kind of speed it up. So really all I can do at this point is treat any pain I have. So I'm still taking pain meds, and then just kind of wait it out for the next however long. Could be a couple months, could be a couple of years. So we'll see where it goes. I'm very interested to see where it goes. I'm a little anxious, obviously. Okay, so we are going to do for today. So that's all for that. I'll stop my share and stop my recording. Bye. Okay, thank you. That's recorded now. Okay.